On May 16, 2025, Colonel David Levin, piloting an F-15I Ra'am under the call sign Sword 11, led two formations penetrating Yemeni airspace at an altitude of 24,000 feet. The aircraft operated in stealth mode, adhering to MCON Alpha protocols, with radar signals off and radio silence maintained except for mission-critical communications. Intelligence confirmed that the targeted ports were receiving Iranian weapons shipments intended for attacks on Israel and international shipping lanes. This wasn't just a routine airstrike, it was a mission to protect loved ones and homeland. The desert coastline of western Yemen appeared on the horizon, visibility hampered by coastal humidity, creating a light fog stretching about 9 miles. Levin's navigation display showed pre-programmed coordinates for Piers 3 and 7 at Hodeidah port, where satellite imagery had detected unusual activity over the past 3 days. Thermal readings from warehouses there didn't match the surrounding environment, a clear sign of something amiss. At 3:44 p.m., Sword 11 descended to an optimal weapons release altitude. The internal navigation system counted down to the release point, 87 seconds and closing. The strike package relied entirely on internal systems, avoiding GPS signals that could be jammed and emitting no radar to evade detection. The F-15s maintained precise spacing, each positioned to maximize target coverage while minimizing exposure. This was when thousands of hours of squadron training paid off. The F-15I Ra'am, flown by the pilots, was Israel's customized strike variant of the F-15E Strike Eagle, optimized for deep penetration missions like this. Its wings and fuselage carried 11 hardpoints with a payload exceeding 23,000 pounds. Twin Pratt & Whitney engines propelled the jet past Mach 2.5, providing the speed and range needed to hit targets across the region before adversaries could react. At 3:45 p.m., Sword 11 visually acquired Hodeidah port structures, marked by 2 cranes over 330 feet tall at the western pier. The navigation system highlighted precise aim points on the cruise display, spotlighting a row of warehouses. The pilot's breathing quickened slightly as the weapons officer activated combat mode. All systems were green, and there was no turning back. The jet banked slightly left, aligning fuel tanks in the crosshairs. At exactly 3:46:27 p.m., the first missile left the rail. The F-15 felt lighter instantly as the 750-pound munition detached. 4 seconds later, the formation split, each jet banking sharply in opposite directions. The Rampage missile streaked toward the coast, leaving a thin smoke trail in the clear sky. The F-15I's long-range and low-altitude capabilities allowed Israeli forces to approach Yemen's coast undetected, preserving the critical element of surprise. Without the platform's 1,000-mile combat range without refueling, the Israeli Defense Forces, IDF, would have needed to launch from closer bases, risking early detection by Houthi air defenses. But the mission wasn't over, and now the targeting pod came into play. At 3:47 p.m., Sword 11 activated the Lightning Pod's wide field search mode, and the central display immediately shifted, showing detailed thermal imagery of Hodeidah port. Despite the foggy conditions, the pod's multispectral enhancement cut through coastal humidity like it wasn't there. The FLIR system automatically adjusted gain to optimize contrast between the surrounding desert heat and thermal signatures from port infrastructure. Hodeidah's facilities stood out clearly, with cargo trucks moving between buildings and, crucially, 2 warehouse structures showing abnormal heat signatures. One building registered a surface temperature nearly 7 degrees higher than surrounding structures despite identical sun exposure, an unmistakable anomaly for a standard warehouse. The crew knew they'd found the right target. The navigation system locked on to this anomaly, highlighting it for attack. The warehouse matched intelligence assessments of a suspected weapons cache, but visual confirmation would trump thermal signatures alone. Just then, the pod's camera spotted a box truck backing into the western loading dock. The Lightning's thermal sensors detected a temperature differential between the truck's cargo area and its exterior, consistent with heated metal from munitions retaining warmth longer than the environment. This confirmed it. They'd located the primary target. The Rafael Lightning III pod, a fifth-generation electro-optical sensor and Israel's most advanced for precision ground strikes, was mounted near the F-15I's right engine intake. Combining forward-looking infrared, CCD-TV, and dual-mode laser designation in a single housing, the 440-pound system delivered targeting capabilities that once required multiple specialized aircraft. With it, the F-15I became a complete combat package. At 3:48 p.m., the Lightning pod began laser designation on the warehouse, emitting coded pulses reflecting off the target with precise timing. The system automatically compensated for the F-15's motion, keeping the laser within 6 inches of the aim point despite the jet's movement. The Popeye missile's seeker picked up these reflections, confirming target lock with a 97% hit probability. The weapons officer verified the solution and Levin ordered free fire. The missile left the rail, its main engine igniting less than a second later. The Lightning pod instantly switched to battle damage assessment mode, widening its field of view to cover the entire target area. Impact occurred almost immediately. The warehouse roof's temperature spiked to over 2,200 degrees Fahrenheit as the warhead penetrated. Multiple secondary explosions followed every 2 seconds, confirming initial suspicions. This was a major weapons cache. The pod's autonomous tracking and laser designation enabled precise strikes on 2 targets simultaneously while maintaining radio silence. Without it, pilots would have relied on GPS coordinates alone, useless against moving convoys or rapidly changing scenarios. Here, visually confirming a moving truck at the suspected arms depot turned a speculative strike into a verified hit. While electro-optical systems handled known targets, the team still needed to identify hidden or radar-shielded threats. That's when the main radar came into play. At 3:48 p.m., Captain Sarah Navin on Sword 1-4 banked towards Salif port for the operation's second phase. A problem arose. Meteorological sensors detected a thick cloud layer over the target area, obscuring nearly 90% of the port facility. The Lightning pod's thermal imaging couldn't penetrate this humidity level. Passive sensors fell short, forcing a shift to active mode, a critical decision. Going active risked alerting Houthi air defense networks to their presence. Without radar, however, they couldn't see the target. The pilots weighed their options: abort a strike or accept heightened risk. The mission's importance ruled out cancellation. The decision was made to go active, activating the AN/APG-70 radar system. This powerful sensor switched from terrain following to synthetic aperture mode. After a brief initialization, the radar began mapping the ground below, piercing the cloud cover that blocked optical sensors. The jet emitted detectable signals, but side lobe suppression technology minimized detection risk at this range. It was a calculated gamble, but worth taking. The cockpit display showed a detailed radar map of Salif port. Storage tanks appeared as distinctive circles, while pier structures showed as rectangles extending from the coast. The synthetic aperture radar was strikingly clear despite the weather and altitude. The radar analysis highlighted an anomaly, a structure northwest of the main pier. Analysis revealed reinforced concrete with denser steel elements than typical commercial buildings. Its radar return matched a fortified bunker or underground fuel storage, exactly what they were hunting: critical infrastructure hidden from satellite observation. This was the perfect target for the Rampage missile's penetrating warhead. The AN/APG-70 radar, integrated on the F-15I, was a multi-mode, long-range fire control system designed for both air-to-air and air-to-ground combat. Mounted behind the jet's distinctive nose, it featured a mechanically scanned array operating across multiple frequency bands. Its antenna could tilt in both azimuth and elevation, providing superior target coverage regardless of the jet's position relative to the ground. This flexibility let pilots maintain optimal flight paths while mapping and targeting ground structures with remarkable accuracy. At 3:49:13 p.m., the radar detected an electronic signal at bearing 085 degrees, matching the signature of a Houthi coastal defense radar. Signal analysis placed it 17 miles away, beyond the effective range of known Houthi air defenses. Still, it was a reminder to act fast. The APG-70 automatically calculated optimal launch timing and altitude, relaying targeting data to the Rampage missile system. The weapon status indicator confirmed readiness. Only one task remained. At 3:49:42 p.m., the Rampage missile detached from its rail and separated from the jet. Navin immediately banked, executing a pre-planned egress route. The radar had done its job, providing targeting through weather that optical systems couldn't penetrate. Without this capability, the strike would have been aborted or limited to less valuable targets. Now, the missile was en route to the fortified facility, and the final phase loomed. At 3:49 p.m., Captain Navin observed the Rampage's solid fuel motor ignite, rapidly accelerating the weapon to nearly 1,000 feet per second. This wasn't an ordinary bomb, but a hypersonic hunter with one purpose: to destroy hardened targets. The missile's carbon fiber airframe glowed as it broke the sound barrier. Control fins continuously adjusted for crosswinds, ensuring it stayed on its programmed path despite turbulent coastal airflows. The missile executed a precise sequence, accelerating to speed, cruising to cover distance, descending for the attack run, and then the terminal phase for final approach. Its navigation system maintained pinpoint accuracy throughout, even under forces exceeding 7G in final maneuvers. In its terminal phase, it dropped to just 100 feet above the ground, too low and fast for most air defenses to track effectively. Waypoint data confirmed the missile passed checkpoint Alpha on schedule, sustaining over 715 miles per hour. It hugged the terrain, with radar altimeters constantly updating ground clearance to keep it high enough to avoid collision, but low enough to evade detection. This wasn't just a bomb, but a precision tool executing a meticulously coordinated strike. The Houthis never saw it coming. At 3:50:24 p.m., satellite sensors detected a massive thermal explosion at the target coordinates. The missile had hit its mark. Thermal patterns confirmed successful penetration before detonation, as designed. Rapid secondary explosions followed as stored fuel or munitions ignited. The underground facility the Houthis thought was secure became a raging inferno. The Rampage missile was a long-range, hypersonic air-to-ground weapon, evolved from Israel's extra artillery rocket and adapted for air launch. Mounted under the F-15I's wings, it featured a distinctive tail and compact nose housing electronic guidance. At 15.4 feet long and 1,250 pounds, it carried a 330-pound penetrating warhead capable of punching through nearly 6.5 feet of reinforced concrete. It was built to destroy high-value infrastructure that adversaries tried to shield with fortification and concealment. Meanwhile, at Hodeidah, a second Rampage missile, launched from Sword 1-1, targeted the crane foundation at Pier 3. It accelerated to Mach 1.5 in its terminal phase, diving toward the target. The weapon's hardened steel nose pierced the steel-reinforced structure like cardboard, penetrating before its delayed fuse triggered for maximum effect. The warhead detonated inside, creating immense pressure in the confined space. The blast wave propagated through connected underground areas, triggering a chain reaction as secondary explosives ignited. The pressure wave caused widespread structural collapse, completely severing the reinforced connection between the pier and crane foundation. What took months to build was obliterated in under a second. Post-strike satellite imagery confirmed total devastation at both target sites. At Salif, the underground fuel storage facility reached over 1,470 degrees Fahrenheit in under a minute as petroleum tanks burned uncontrollably. At Hodeidah, Pier 3 was neutralized, along with over 52 feet of reinforced pier infrastructure. The Rampage missile gave Israeli pilots the ability to strike fortified facilities from a safe distance, avoiding exposure to air defenses. Without this long-range capability, they would have needed to drop bombs directly over the target, putting aircraft and crews at risk. The operation wasn't over yet, with one more surprise for the Houthis. At 3:52 p.m., Lieutenant Colonel Avi Stern held Sword 1-3 steady at 18,000 feet, maintaining a data link with a just-launched Popeye missile. This wasn't a fire-and-forget weapon, but a pilot-guided munition requiring continuous control until impact. The Popeye streamed real-time video to the cockpit with broadcast quality, giving Stern a missile's eye view as it approached the target. It was like piloting a kamikaze drone. The tactical display showed live footage from the missile's nose camera as it streaked toward Hodeidah's southern pier at over 460 miles per hour. Stern made slight adjustments with his thumb on the control stick, sending commands via an encrypted data link. The missile responded instantly, its control surfaces shifting to follow his guidance. This level of precision set the Popeye apart from other long-range weapons. It combined human decision-making with a missile's speed and power. The target was a substation adjacent to the crane foundation, not just a power node, but the hub supplying electricity to the port's entire cargo handling system. Destroying it would render the port inoperable, regardless of other surviving structures. A perfect strategic target for a precision strike. Stern fine-tuned the approach as the missile closed in, ensuring an optimal impact angle for maximum effect. The data link held strong despite the distance, with military-grade encryption preventing interference or hijacking. At 650 feet from the target, the laser rangefinder confirmed the final measurement, and the missile's fusing system updated for optimal detonation. This was precision warfare at its most advanced. The target was in sight, and the strike was a go. The Popeye, also known as Have-Nap, was a long-range air-to-ground missile used by the Israeli Air Force for precision strikes on hardened targets. Mounted at the F-15I's centerline station, its 17.7-foot cylindrical body featured mid-body control surfaces. Weighing 3,000 pounds, including a 750-pound high-explosive fragmentation warhead, it delivered massive destructive power with surgical accuracy. Unlike fire-and-forget weapons, it maintained a video data link with the launching aircraft, enabling real-time control until impact. At 3:52:38 p.m., the Popeye struck the substation with pinpoint accuracy, within 20 inches of the aim point. The warhead penetrated the reinforced concrete exterior before detonating, unleashing a devastating pressure wave that shredded the facility's interior. High-voltage connections were severed instantly, triggering a cascading power failure across the grid. The blast's pressure wave was so intense that sensors on the F-15I detected it from miles away and thousands of feet above the impact. The Lightning Pod's camera captured the complete destruction of the power distribution hub, burning at nearly 1,800 degrees F and rapidly spreading to adjacent structures. Without power, the port's cranes, cargo equipment, and security systems were paralyzed. From another jet, a final Popeye missile was launched, targeting Salif's main pier. This missile aimed at a fuel distribution point where pipelines met the loading dock. The missile struck with precision, within 3 feet of the aim point, hitting a reinforced concrete structure housing critical flow control valves and pumping equipment essential to port operations. The impact caused an immediate structural collapse of the fuel handling system, rupturing high-pressure pipelines carrying thousands of gallons of fuel. The ensuing fire spread rapidly, consuming about 80 gallons of fuel per second and producing a thermal signature visible to satellites hundreds of miles in orbit. The blaze engulfed nearby storage facilities, ensuring both ports would require months of reconstruction before resuming operations. This airstrike showcased the precision and power of modern military technology. If you found this account compelling, hit like, share, and subscribe for more gripping content. Thanks for following along.